Okay, let's look at density. We are going to be starting from the scratch because we want to carry everybody along. So from the definition I've written here, it said the density of an object is the mass of the object per unit volume. So mathematically, we say density equals mass over volume. And of course, this is a symbol for density. It is called rho. It's a Greek letter, and that is the sound. That's the how you pronounce the word rho for this particular symbol. So mathematically, this symbol is acceptable. So we can write it this way: rho equals mass over volume. But most times when we are doing calculations, because of time and how you start trying to get the exact sketch of this particular rho, we'll just say D equals mass over volume to save time. It's still acceptable because we know our D stands for density. Now, for the unit for this density, the mass has a unit for kilogram. One of the units for mass is kilogram, and one of the units for volume is meter cube. So we are going to have kilogram per meter cube. So you can write it this way also, still the same as this one. So you can write it kilogram per meter cube, or you write it this way. So everything will now be on a horizontal stretch, kilogram per meter cube, still the same thing. But if you have your, like in a laboratory, and you have your results in your lab, the results might come in gram per centimeter cube. That means the mass might actually be in gram and the volume might actually be in centimeter cube. So you now end up having gram per centimeter cube, which is, we can be written this way also, gram per centimeter cube, still the same as this one. But if you now decide, because mostly the acceptable unit is this kilogram per meter cube, so when you have your lab results and you have them in this unit, you can convert back to this kilogram per meter cube by multiplying it by 1000. So for example, I give an example here. This is 5 gram per centimeter cube. Let's say this is your lab result. You can multiply by 1000 to convert it. So if you multiply by 1000, you get 5000 kilogram. You can now attach the kilogram per meter cube because you've converted that way by multiplying by 1000. So let's look at the layman meaning of density. If someone should ask you or bring two objects to you and say which one is denser or which one has more density, you could actually pick the one that is looking thicker. So the thicker one is the one with more density. That's a layman idea for objects with density, with their densities. So the thicker the object, the more dense the object, or the denser the object. So even in liquids, there are some liquids that are thicker than some other liquids. Let's look at blood and water now. So we know blood is thicker than water. So we could say that blood is denser than water, or blood has more density than water. And what brings about that thickness is actually the mass of that particular object, because for this density, if we are looking at a particular material, we are trying to get the mass and the volume of that material strictly under this topic, the mass and the volume of the material. But the more the mass of that material, the more the density. Simple. Under your fractions, you should know that for fractions, if you have 2/7 and you have 5/7, and we are saying, okay, this 2 represents the mass and the 7 represents the volume, and also this second fraction, the 5 represents the mass and the 7 represents the volume, we know that this fraction is bigger just by looking. You know now 5/7 you can also look at it like 5 out of 7. So if you give someone 5 out of 7, it's better than giving someone 2 out of 7. So this fraction is bigger than this. So definitely this, if you simplify this, if you now use your calculator to do 5 divided by 7 to get your density, you have a greater value than this, because the mass here, which is 5, is greater than the mass here, which is 2. And aside that, you could look at it this way. Attach proportion to it now. We could use the horizontal test in the formula. I said we are going to be using D most times. So if we use the horizontal test as this way, we could see that D and M are in the same horizontal field, and that means D is proportional to M since they are in the same horizontal field. And we could use the diagonal test since D and V are now in the same diagonal field. That means D and V are inversely proportional, and know the difference between them. If two quantities are directly proportional, it means if you increase one, the other one will increase. That is it. So now, since we now know that the density and the mass are directly proportional, if I increase the mass, it means I'm increasing the density of that particular material. Or if I increase in density, it means the mass is also increasing. Then let's go to now the density and the volume. Since we know that they are inversely proportional, for inverse proportion, when you increase one, the other one will reduce. So if I increase the volume, it means I'm actually increasing the denominator in this fraction to make it look more smaller. Imagine if I increase this 7, and I end up having 100. So I have 5 over 100. Imagine you giving 5 out of 100. No. It means you're not generous enough. In fact, this 2 out of 7 now becomes greater than 5 out of 100. So the more I increase the denominator, the lesser the density of that particular material I'm trying to calculate, if you are looking at 5 as your mass and 100 as your volume. So now that we know that the density and the volume are inversely proportional, that means if you increase the volume, the density will keep reducing, or if you are increasing the density, the volume reduce. We now know that the greater the denominator, the lesser the density. The higher the numerator of this fraction, the greater the density. So that's easy. Don't forget kilogram per meter cube or gram per centimeter cube. You can convert from here to here by multiplying by 1000. Very easy. So let's see how we could solve a simple example. Now that we know the formula, the mathematical representation, we know density is mass of that object divided by its volume. And don't forget, once you see the kilogram, you know that, okay, this is the mass, the value of the mass. And once you see the meter cube or centimeter cube, you know that this is the value for the volume of that object. And don't forget that we could also be calculating. Let's look at this cylinder now, and we want to get the density of the cylinder. We want to know how closely packed. Ask yourself, how closely packed are the particles of this cylinder? How thick is this cylinder? So we know that to get the thickness, we know that density equals to the mass of the cylinder divided by the volume of the cylinder. And we could just easily get the mass, but the volume, since it's a cylinder, we could use a direct formula to get the volume. What's the volume of a cylinder? The formula for calculating volume of a cylinder is pi r square h. So most times questions can come that way, and you start looking for how to get the volume, but they might give you the right parameters, that's the radius and the height. So let's see a question like that here. So this is one of the questions. So it said a solid cylinder of base radius 0.1 meter and height 0.8 meter weighs 88 kilogram. Determine the density of the material. So without wasting time, we know that density equals to mass over volume. Then, okay, let's start writing out the parameters. We need the mass and the volume. We need to divide them to get the density. Very straightforward, but it seems we don't have the volume yet, but the mass is there. The mass equals the one in kilogram, which is 88 kilogram. And the volume, we don't have anything in meter cube, but we have something like a radius and a height, since they're talking about a cylinder. So we can find our volume ourselves and fix here, so that we can impute them into the formula. So since the solid is a cylinder and they gave us the radius and the height, we can by ourselves find the volume and fix here. So first of all, volume of a cylinder, or the formula for calculating volume of a cylinder, is pi r square h. So let's use 3.142 as our pi, times the r square means r times r, and the r is what, 0.1. So I'm going to say 0.1 times another 0.1. Remember, it is being squared. R square is r times r, and the 0.1 is my r. Then times the height. What's the height? 0.8. So I'm going to use my calculator. So using the calculator, I have 3.142 times 0.1 times 0.1 times 0.8. Okay, so I have 3.1, not switch it on yet. So 3.142 times 0.1 squared, let's not waste time, then times 0.8. So that will give us 0.025136. So that's 0.025136 meter cube. And take note of the units. We have meter here, we have kilogram, we have meter. That means our density can definitely have the kilogram per meter cube unit. since everything is in place. The meter is there to attract the meter cube, and the kilogram is there to fill in the spot here. So we are good to go. No need of converting anything. Our answer will just attract the kilogram per meter cube. So now that we've found the volume, we can now write our volume as 0.025136 meter cube. We can now find our density. So density equals mass over volume. What's the mass? 88 divided by the volume, 0.025136. So dividing, it's 88, sorry about that, 88 divided by 0.025136. So we're going to have 3,500.95. So the density is 3,500.95 kilogram, approximately, actually, because we rounded off to 2 decimal places. So approximately 3,500.95 kilogram per meter cube. So that will be the unit. So that's it. So this is the first example. So we're going to go further. This is just the basics. I know this might look so boring for those that already know it, but remember, we're here for those that don't know it. So good luck. We're going to be doing more videos on density and relative density.